Okay, so in cycle 3, once again. So in cycle 3, EOR instruction is there in the execution phase, ALU phase, but the execution of the EOR instruction is not completed by the ARM processor because here, so in the cycle 3, so LDRB instruction completes. After completing the cycle 3, only the data R1 which is required by the EOR instruction is ready. Okay, so after completing the cycle 3, cycle 4 begins. When the cycle 4 begins, so EOR is in the ALU phase, and all the data, so that is the source 1 R0 and source 1 R2, both the data are ready in the register bank, and the ARM processor completes the execution of the EOR instruction at the end of the cycle 4. So that is why here the processor will take 4 clock cycles to complete the execution of these 3 instructions because of one cycle interlock which is caused by the LDRB instruction. Remember here, EOR instruction, execution of the EOR depends on the result which is generated by the LDRB. So this is the data R1 which is required by the EOR. So execution of the EOR is possible only when the LDRB instruction execution is completed. So that is why processor has taken 4 clock cycles, Okay. So now consider, so here, so how the branch instruction is scheduled by the processor. So here we have branch instruction. So in order to complete the execution of these instructions, the processor is taking totally 5 clock cycles. Okay, so totally 5 clock cycles. Why it is taking 5 clock cycles? Because of the branch instruction, the processor has to flush the pipeline contents when it is jumped from this instruction to this instruction. Okay, so let us consider the example how the instructions they will appear in the pipeline. Okay, see here. So the move instruction, we assume that the move instruction is there in the ALU phase of the pipeline, and this B instruction, branch instruction, is there in the decode phase. Add instruction is there in the fetch phase. Okay, so in the cycle 1, so move instruction is the first instruction that is there in the ALU phase. Okay, so move instruction, so it is very simple instruction. So perform the addition, copy the content of this register. So copy the immediate value 1 into the R1 register. So in the cycle 1 itself, the execution of the move instruction is completed. So at the end of the cycle 1, the result is available in the R1 register, that result of the move instruction. Okay, so when the cycle 2 begins, the branch instruction enters into the ALU phase, and instruction enters into the decode phase, and the next instruction EOR instruction enters into the fetch phase. Okay, so now in cycle 2 we have EOR instruction in the fetch phase and instruction in the decode phase, branch instruction in the ALU phase. Okay, so now see here what happens. The branch instruction means the address of the label. Case 1 is a user defined label. So address of this label should be loaded into the PC. Okay, so at the end of the cycle 2, the ALU phase of the branch instruction is completes. Okay, that means the address of the program, label case 1 is loaded into the program counter. Now the processor will jump to this label by skipping the execution of these two instructions. Okay, so here what happens? These two instructions are AND instruction and EOR instruction. They are already in the pipeline. So EOR instruction and instruction, they are already in the pipeline. But the processor has to flush out these two instructions from the pipeline. Okay, and the processor has to bring the new instruction into the pipeline fetch phase of the pipeline. So that happens in the cycle 3. So in the at the end of the cycle 2, the processor will remove these two instructions from the pipeline. Okay, because the address of this label case 1 is loaded into the PC. So PC is pointing towards this memory location. In this memory location, this instruction is there. So processor has to execute this instruction by fetching the sub instruction. So that is why at the end of the cycle 2, the processor removes these two instructions. Removing is nothing but flushing out these two instructions from the pipeline, and at the beginning of the cycle 3, the sub instruction enters into the fetch phase. Okay, and in the beginning of the cycle 4, sub instruction enters into the decode phase, and in the cycle 5, the sub instruction enters into the ALU phase. At the end of the cycle 5, the execution of the sub instruction takes place by performing subtraction of R0 minus R1. The result is stored in the R0 register. So at the end of the cycle 5, the sub instruction is execution is completed. So that is why here, because of pipeline flush or because of this branch instruction, processor is taking 5 clock cycles for the execution of these instructions. Okay, so